Hello, and welcome to today's lesson. We're in Circles and Polygons Unit 1, Lesson 6. In this lesson, we're going to be looking at a very specific type of measurement within shapes, and it's called the midsegment. So we're going to see how the midsegment works within triangles and how the midsegment works in trapezoids. So when we look at what a midsegment is, a midsegment, breaking down its name, it's a segment that connects the midpoints of two sides of a triangle or two sides of another shape. Okay, the segment connecting the midpoints of two non-parallel sides, okay, and that's very important when we're working with the trapezoid. So we're looking at non-parallel sides. We know that triangles don't have parallel sides. So when we're looking at midsegments, we're looking at connecting sides that are non-parallel. So if we look at this triangle below, we can see that we've divided up all the sides into equal parts. So we've found the midpoint of all of the sides, and then we connect those midpoints to make a mid-segment. And with that mid-segment, we have the three mid-segments conjecture. Okay, the three mid-segments of a triangle divided into four congruent triangles. Okay, and the congruence happens since we're cutting each side in half. We know that the very last side also has to be cut in half. So we can take this triangle, we can see how it matches here, matches up here, and then finally, if we rotate it, we actually get a match with the inner triangle. Okay, so when we look at missing pieces of a triangle that has been intersected with midsegments, what we want to know is we're always looking for tick marks. Tick marks tell us that we have equal measurements. So we have 15 for Y because we're cutting that bottom segment in half. We're cutting the left side in half. So if we have 13 for the upper tick mark, Z is equal to 13. And the same thing on the right-hand side. We have the equal tick marks. That tells us that this is a midpoint, and that means that the lengths have to be congruent. Now we can also take these measurements and copy them into the inside of the triangle. So we have our inner triangle in the middle. 15 is now this upper portion because it's been rotated. We would have 14 over here and 13 there. So we can see that all of these triangles have a 14, a 13, and a 15. So when we look at angle measures, once again, we can use the idea of the equal triangles, knowing that if we have 45 at the bottom, that 45 has to be copied into this angle as well. And we would also copy it here and here, because every triangle made up of the three angles, we have the left angle, the upper angle, and the right angle in this picture. So knowing we have the 95 at the top of this angle, the 95 has to be copied down into this piece. And it's using that three mid-segment conjecture, knowing that if we connect all the mid-segments of a triangle, we create four congruent triangles. And if they're congruent, their angles have to be equal and their side lengths have to be equal. So now, finishing up, we have the 40. So then the 40 would get copied to angle C. And if we want to finish all of our pieces, we've got the 95 degrees here, the 40 degrees here, and now we can also prove some of our pieces about a linear pair and a triangle, the three angles of a triangle adding up to 180. So if we wanted to look at how the midsegments work with some different types of triangles, if we have an equilateral triangle, We're cutting each of our segments in half. These two are equal. These two are equal. Notice that I use the same amount of tick marks, because if we're cutting the sides of an equilateral triangle in half, then all of those side lengths would have to be equal, and the triangle that we create would also be an equilateral triangle. And with any equilateral triangle, we know that the three angles are all 60s, so we could copy that into all of the portions of the triangle to finish that up. Now, if we're looking at mid-segments of a right triangle, cutting each side length in half, we're cutting this one in half, cutting this one in half. Once again, using the three mid-segments conjecture. Now, these lengths are not necessarily all equal, but notice what we've done. If we've cut a triangle that is a right triangle to start with, if we cut all the mid-segments out, we create right triangles for all of the others. So now, looking at the trapezoid, remember when we're talking about the mid-segment of a trapezoid, it's connecting the non-parallel sides of the trapezoid, and we have our trapezoid mid-segment conjecture. The mid-segment of a trapezoid is parallel to the bases as an equal in length to the average of the lengths of the two bases. So in this case, the middle segment of the trapezoid is half, or the average, of the two bases. So now let's put that conjecture to work. If we have 14 for the upper base, 24 for the lower base, x is going to be the average of those two. So we have 14 plus 24 divided by 2. And we have 38 divided by 2, which is 19. Okay, and if we think about an average, how do we get the average? We add 5 to get to the 19. We add 5 more to get to the 24. So we can see that we've averaged that value. And now if we think back to our properties of trapezoids, if we have parallel lines and the mid-segment is parallel, then we can use that to find all of our missing pieces, knowing that on any side of a trapezoid there can only be two possible angles, and those angles have to be supplementary. They have to add up to 180 because of how parallel lines and transversals work together. So we could put in the corresponding 60-degree angle here and look at our linear pair to get the 120. Same thing on the other side. The 70 would be transferred up to B, corresponding position. We could transfer that 70 up above C and then use the idea of a linear pair to solve for C. And just another example here. This is where we go to an extension problem trying to find one of the base values when you're given the middle value or the mid-segment length. And you could use the idea of the average, x plus 26 divided by 2 has to equal 15. And then we could cross multiply and solve. X plus 26 equals 30, and then solve for x, which would be 4. Okay, but we could also use other process types for mid-segments. From 26 to 15, we're going down 11. So if we go down 11 more from 15, we end up at 4. Okay, and that concludes our lesson for today, a really quick one, looking at the idea of a mid-segment in a triangle and in a trapezoid. And in your homework, be very careful with the perimeter problems. Okay, what perimeter are you looking for? The whole triangle or the small triangle at the top or in the middle? Thank you and have a great day.